So let's refresh degrees in a circle, and most of us are pretty comfortable with this. If I draw myself the best circle I possibly can, try and draw yourself a good circle. And I center my circle on a coordinate plane. I have an x-axis and I have a y-axis. The coordinate plane gives me a place to start when I'm moving around the circle. And my starting position is the ray that comes out from the center. I'm trying to make it really dark so you can see it. It's the ray that comes out from the center and heads in the positive direction of the x's. This starting point is known as standard position. And as I move around the circle and create angles from that starting position, if I move counterclockwise, I form positive angles. So this is a positive direction. Counterclockwise is positive. It seems like it should be the other way, but it's not. Counterclockwise is positive. If I move around the circle and create angles along this circle, and I move in the clockwise, that creates a negative angle. And that's a weird concept to us. As we move around, it doesn't seem right to have a negative angle. Have you heard of an angle that measures negative 90 degrees? No. But it's not about the sign of the angle, but instead the direction the angle is going. Okay, so if I move clockwise, I move in what I call a negative direction. If I create an angle, like let's say I finish this angle off, I'm creating an angle and I'm using that little sort of angle mark here to indicate the direction and kind of the size. This end that stops here is called the terminal end. And I'll move my big fat hand in a little bit. Or the terminal side is better. Terminal side. It's the ending side. So I have a standard position. This is where my angle starts. Where my angle ends is called the terminal side. And as I move around in degrees, I always think it's fairly obvious just by the shape of the axes that we're graphing on. So my starting place would be at 0 degrees. Is that you? How do you know it's you?
I have a customer account. But it's nobody. So.
Oh, okay. If I get up to the y-axis, the top of the y-axis, right at that tippy top point, I am at 90 degrees. If I move all the way to the other side of the x-axis, I'm at 180 degrees. How many of you feel pretty comfortable with this? Like, yeah, we know this. Okay, got it. Good. So if you're confident in this, great. It's going to make things nice. 270 degrees, I end at 360 degrees. If I move backwards in my negative direction, I'm going to try and find my matching pen. Okay. This would be negative 90 degrees on the bottom where 270 is because it's moving backwards. That would be in this direction, negative 90. Negative 180 falls in the same spot as positive 180. Negative 270 up here. Sorry that I didn't give you a whole lot of room to squeeze this stuff in. And then negative 360 will be over here by 0. And I can keep moving around the circle. Now, we in algebra didn't encounter angles that were over 180 degrees. But in trig, we do encounter angles that are over 180 degrees. We can even have an angle that's 1,000 degrees. It just means it keeps moving around and overlaps itself. Now I started with the degrees because that's the one we connect with. And when we graph our angles in degrees, what we're going to be looking for most importantly is where they land. Because where they land is going to determine a lot for us in our not so distant future. So we talk a lot about quadrants. And what's important to know about the quadrants on a coordinate plane is what the signs of the coordinates would be in that quadrant. So in quadrant 1, I have all positive points. In quadrant 2, I have all negative positive points. In quadrant 3, I have all negative points. And in quadrant 4, I have all positive negative points. Okay? Review, a little bit of new, maybe direction. Degrees, like I said, are something we're comfortable with, and it'll help us get a start on our movement. But we are going to switch gears very quickly to something called radians. Have any of you heard of radians before? Have you done where you switch from radians to degrees and degrees to radians? Okay, some of it depends on the algebra teacher that you had or algebra 2 teacher that you had, where you took algebra 2, all that kind of stuff. But that's something that you've done in the past. What I need to do is break you of the habit of translating, because we want to get out of our comfort zone in degrees and move into a new comfort zone in radians for trig. Because everything in trig and pre-calc and calc works best with radians. And so radians are just a different way of measuring an angle. And a radian is the ratio of the angle. Actually, I should be specific. That's central angle to the length of the radius. Okay, so it's just a ratio or a fraction of the central angle based on its, or central angle actually translates to its arc length. Okay, so central angle, ratio of the central angle, which translates to the arc length, over or to the length of the radius. And so I'm going to draw another circle. I should have drawn my circle first. Try to center it as best I can on my circle. And we start in the same position. We still have our same standard position. We still move in the positive direction when we go counterclockwise. And we move in the negative direction when we go clockwise. And we still start at 0, but it's 0 radians. It's actually 0 pi, but we don't need to write the pi on it. and we end at 2 pi. So instead of one lap around a circle being 360 degrees, we take one lap around the circle being 2 pi. So that means that halfway around is pi, and a quarter way around would be half of pi, or pi over 2, and 3/4 of the way around would be 3/4 of 2 pi, which is 3 pi over 2. And when we move backwards, as long as we're comfortable again with our radians, moving backwards just changes the sign to negative and sort of flips their position. So this would be negative pi over 2 is equivalent or lands in the same spot as 3 pi over 2. Negative pi, negative 3 pi over 2 up here. And then negative 2 pi is over here by 0. And I know this is a little squishy. We're going to draw this picture so many times. It's going to be kind of ingrained in your brain. But before we get into drawing our pictures, I want to get comfortable moving around. And so we're going to draw some angles. Remember, we have our standard position. Wherever we land, our angle is our terminal side. And I'm interested in the quadrant that the terminal side lands. So if I want to do 550 degrees, like I said, we're used to 180 degrees or less. But when we draw our angle in standard position, we just kind of keep counting our way through. So when I draw this, one lap puts me at 360 degrees. Good? So this is me one lap around my circle, 360 degrees. If I go one more movement up, that's just 90 degrees added onto it. So 360 plus 90 is 450. Good? I need to get to 550. So if I add 90 more, I'm at 540. I'm almost there. I need to go 10 degrees more. And then I draw my terminal side to my angle. So again, I'm just kind of working my way around and kind of counting. 90, 180, 270, 360, 450, 540, 10 more puts me at 550 degrees. Now, I am not ever going to go to your picture and measure and get a protractor out and say, hey, friend, that doesn't look like 10 degrees. That's not the important part. I just know 10 degrees is less than 90 degrees, right? And so if it's less than 90 degrees, it's not going to go past this next side. I label that with my drawing. I landed in the third quadrant, and now I'm done. Okay? So degrees. Let's do radians. Don't be afraid of the radians. Sometimes we're scared because we see the fractions, and I don't want you to be afraid of the fractions. They're really easy to work with because whole pies are going to land on the x-axis, half pies are going to land on the y-axis, and then any other thing in between will land in a different quadrant in between. So what I always do is I think of things in terms of whole and half pies. I'm going to take this first guy and I'm going to write it as an improper fraction. So 9 goes into 25 2 whole times, right? Because that would be 18. And then I do 25 minus 18 leaves me with 7/9 pi more. So all this tells me is I am going to go one lap around because that's 2 pi. and then almost pi more, because 7/9 is almost a whole pi. It's more than a half a pi because 7 is more than half of 9. If you are like, fractions make me cry, become very close friends with your calculator and the fraction key on your calculator. Because if I plug in 25 fraction 9 and hit enter, my calculator will convert it into 2 7/9 right away for me. If you have a different kind of calculator and yours doesn't, just let me know. I'll tell you how to do it. It's usually just a keystroke or two that puts it in the right form. Okay? All right, so here I am at 2 7/9. So this says 2 pi is 1 lap around. So my terminal position, 1 lap around, 2 pi. 7/9 more. 4 1/2 would be half a pi. 7 is more than 4 1/2, so I'm going to go over here. I draw my angle. I landed in the second quadrant. It's all about the fraction of movement. Remember I talked about negative. Negative just means backwards. How do we translate backwards when we draw a picture? We still start in the same position. I just move clockwise instead of counterclockwise. So I want to move backwards 400. Well, backwards 1 lap is 360. If I move 90 more backwards, I am at 360 plus 90, 450. I want to be at 400, so I'm going to stop before I get to 450. That landed me in the fourth quadrant. All right. Backwards 15/4. Same thing. 4 goes into 15 3 whole times. Left with 3/4 pi more in the backwards direction. Don't treat that negative like a negative. Treat it as a backwards movement. So whole pies. I start here, 1 pi, 2 pi, 3 pi, 4 pi. All of my odd pies are going to be over here on the left-hand side. All of my even pies are going to be over here on the right-hand side. So if I go backwards, it's backwards 1 pi, 2 pi, 3 pi. So I'm moving myself, starting position, backwards 1 pi, 2 pi, 3 pi. Is 3/4 more than a half pi? Yes. So I have to move more than a half pi. Remember, each of these blocks here are half pi. I landed in the first quadrant. Now, what gets a little messy, and again, another thing that gets a little confusing to people sometimes, is when we kind of focus on radians. It's important that we understand just because it has pi in it doesn't make it a radian. What makes it a radian is that it doesn't have degrees. So this is not 2 degrees. This is 2 radians. But where is the pi? If I don't see the pi, it is embedded in the radians already. So what I want to do is take this 2, and I want to get the pi out. I'm basically multiplying it by pi over pi. And so I'll introduce the last pi in there, but I'm going to get the pi out. 2 divided by pi leaves me with 0.6366. Bless you, bless you, bless you. So this translates to 0.6366 pi. 66 pi. Don't round too quick. Don't just call this 0.6, because if we round to 0.5, that means I'm on an axis. 0.5 is a half. So make sure you figure out how much over you are. So don't round too much. So this is 0.6366 pi. 0.6366. Talk to me about size. Is 0.6366 more than 1 or less than 1? Less than 1, right? There's no whole number on it. Okay? Is 0.6366 more than a half or less than a half? More than a half, because a half is 0.5. So I'm moving less than 1 pi, more than a half pi, in the positive direction. So I'll start my angle. More than half, less than 1, landed in the second. Once you get comfortable with pies, they make it easy to kind of move and count through. It makes angles, degrees seem very, very difficult in the whole scheme of things, all right? So if I have no degrees, I assume it's radians. I am going to take the pi out of there. I'll just divide it by pi on my calculator. I got negative 3.183. That translates to negative 3.183 pi. So that says I am moving more than 3 pi, less than 3.5 pi, in the backward or clockwise direction. So it's just me translating. Here's my starting position. 1 pi, 2 pi, 3 pi, less than a half, make my angle. I landed in the second quadrant again. Okay? The next page is all about reference angles. And I don't want to talk about reference angles right now. Now is not a good time for me to bring up reference angles. But what I do want to do is go the other way, and I want to try and find angle sizes. So let's skip our reference angle page for now. We'll revisit that when the time is necessary. And I'm going to go into finding angle measures. Again, today we're going to have some degrees involved, but we won't see a whole lot of degrees in the near future. We're going to be converting almost strictly to radians. If it says degrees, my answer should be in degrees. If it says radians, my answer should be in radians. Okay? And I want to find the angle measure of each. My angle is this whole thing here. I know that each of these are 90 degrees. And so if this little measure here is 75, what's the missing piece? 15. And so if I go halfway around the circle plus 15 more, I'm at 180 plus 15, or 195 degrees. Okay? I want to use that same concept with radians. So if every measure around here is pi over 2, pi over 2 is equivalent to 90 degrees, then this little piece right here is pi over 2 less pi over 3, because pi over 3 was given. Good. Or it is 1/2 minus 1/3 pi. I can treat it like that, because my calculator My calculator can't handle pi in the fraction. Those people that have that white calculator, yours can. Mine can't. So I have to do it that way. So I do my 1/2 minus 1/3 and get 1/6. So that little piece translates to 1/6 pi, or we call it pi over 6. Okay? So I'm doing the same kind of thing that I did on the last one. I'm moving halfway around the circle. I should be doing on this one. Halfway around the circle plus that little piece more. So it's halfway around the circle pi plus pi over 6 more. So when I do my calculation, I go pi plus pi over 6. Or I translate that as 1 plus 1/6 pi. Or 7/6 pi. And I'm taking it really slow right now. We'll get much quicker at this, but I just want to make sure you see what's going on. Or 7 pi over 6. Final answer. Don't forget, when you move backwards, it puts a negative in front of it. Keep in mind, we don't want to treat it like a negative. We just want that to be my backwards move. So when I translate this, my missing piece here is what? For 15? 10, yep, if the whole thing's 90 and 80 is used, my missing piece is 10. When I move backwards, I just say, I move backwards 1 lap, 2 laps, plus another 180, plus another 10. So I did 2 times 360, plus the 180 half, plus the 10 little sliver. And again, I'm taking this slow. You don't have to write that all out, but that's what my brain is going. But I don't want to forget, this whole thing is backwards. So I moved all of that movement in the backwards direction. So when I figure that out, I get 720, 910, is it 910 degrees backwards. Okay, let's do our next one. We're almost done. I'm almost done talking. Just a quick check-in. How's it feel so far? You okay? Okay. Nobody feels like crying yet? Okay. All right, so I need to find this little sliver here. This whole thing, my big fat hand keeps getting in the way. The whole thing is pi over 2. That's a quarter of the range. And so this little piece is pi over 2 minus pi over 4. That'll give me what's left. Again, or 1/2 minus 1/4 pi, or 1/4 pi, once I do the math, or pi over 4. So that's that little piece. That little piece is pi over 4. I am moving backwards pi plus pi over 4. Backwards. Pi plus pi over 4 more in the backwards direction. The backwards stays separate from it. Don't blend it in. That's like backwards 1 plus 1/4 pi, which is like backwards 5/4 pi, which we write as backwards 5 pi over 4. And again, 1 plus 1/4, that's 4/4 plus 1/4, 5/4. It's not my job here to teach you to do the fractions, so again, befriend your calculator if fractions are a struggle. All right? Number 17, 2 things are going to happen. One thing is, what if they give me no indication as to whether I want to give my answer in degrees or radians? Then you are free to give it in any measure you want. I will always give mine in radians. Again, it's easier. I don't have to do 360 plus 360 plus 360 plus 360. Instead, I can just count. And I'm going to count by moving around. So this is 1 pi, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, and a half more. So I moved 5½ pi. Or 2 times 5 plus 1, 11½ pi. Or in pre-calc and trig, we write it as 11 pi over 2. Do you see what I mean by easier to count? Instead of having to do 180 plus 180 plus 180 and function in my calculator, all I had to do was count. 1, 2, 3, 4. Count my pi's, and it makes it kind of nice. Another thing that you're going to encounter is not going to make your life any harder. In fact, it's going to make your life easier, but you do have to know how to interpret it. In all of the previous ones, the 4 that we did above, they gave me the section that wasn't covered by the angle. This one, they're giving me the piece that I need. So I don't have to do any math. I don't have to subtract pi over 3 from pi over 2. All I have to do, again, is count. And so I count 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, and a third pi more. Did I count all right? 1, 2, 3, 4, 5, and a third more. So I do 5 pi plus a pi over 3, which is 5 plus 1/3 pi, which is 5 1/3 pi, which is 15/16 thirds pi, which is 16 pi over 3. And if you left this answer, I would take a half off because it's negative. I moved backwards, yeah. So all the way from the start, we need to remember that this is backwards, 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 backwards. Good? All right. Again, this is a big deal. If something's not sitting right, please let me know as soon as you can. You're going to practice drawing angles, measuring angles, and on your homework you also have a little bit of review.